Trust is one of the most valuable commodities in the world. Without it, the computers and devices we rely on simply cannot operate. This podcast delves inside the concept of trusted computing, looking at the ways standards and specifications can keep you safe from attackers.
Hello, everyone, and welcome to this episode of the TCG podcast. Today, we're going to be talking about the role of standards and specifically how they influence TCG and also what TCG does to embrace standards from other standards bodies. In the last episode, we mentioned the evolution in computing and how that leads to new devices and tech, and also the different numbers of sectors that rely on TPM and TCG standards, healthcare, finance, and education. But today, we're joined by Amy Nelson, who's been with Trusted Computing Group for a very, very long time. And she is going to go a little bit deeper into TCG's role in trusted computing and also how we evolve the standards and how we work with other standards bodies within the organization. My name is Thorsten Stremlau. I am the marketing co-chair at Trusted Computing Group. And Amy, could you just introduce yourself a little bit and tell us about your history at TCG?
Certainly. So I'm Amy Nelson, and I am the chair of the PC Client Work Group. I am also the co-chair of the technical committee, and I have been a member of TCG for a very long time. I can't remember how long. I was not around for the original TCPA and TPM 1.1 days. I entered in the 1.2 days, but I am a past chair of the Security Evaluation Work Group, as well as the longest serving chair of the PC Client Work Group at this point. And my career background is in the client endpoint space. But because of my role on the technical committee and my role within the PC Client Work Group, I get visibility into a broad set of activities within TCG across the spectrum. And for those of you who may not be aware, the way TCG is organized, we have some technology work groups, TPM being one of them. And then we have platform-specific work groups that take those technology standards and essentially tailor them for our specific platform types. And PC Client is one of those platform-specific work groups.
It's great to have you on, Amy. My interactions with you have always shown that you have a very, very broad view of all of the evolving standards that TCG is working on. So in the last episode, we mentioned the evolution in computing that's leading to new devices, new technology, post-quantum cryptography, and the things that we need to adjust. Can you talk a little bit about how you see the role of standards and specifically the role of TCG standards in tech and how they affect the healthcare, the finance, and education subsectors within that?
So TCG has had, the TPM standard for a long time. And then in the platform-specific work groups, we've had, in PC Client specifically, we've had the PC Client-specific platform TPM profile, which essentially defines the requirements for the TPM in a PC Client, laptop, desktop, tablet sort of device class. Because of the ubiquity of endpoint platforms, our platform profile has essentially driven the market for TPM for the most part, and server platforms, industrial platforms have largely leveraged the same TPM that we put in PC Client because the bulk of the TPM shipped go in the average laptops and desktops. So the other thing that PC Client has standardized is the way that the platform instantiates, provisions, and interacts with the TPM within the pre-OS domain. So we have a platform firmware profile specification, and that defines the behavior of the BIOSes for setting up the TPM, and the operating systems that are out there rely on that behavior of the platform firmware so that they can interact with the TPM in a way that provides the broadest possible set of features and security capabilities. In addition to those sets of standards that essentially define how the endpoint itself interacts with the TPM and how OS and software on the box interact with the TPM, we have other standards within TCG around attestation of the platform, attestation of the firmware running on the machine that provide customers in various segments, and I wouldn't say just finance and healthcare. It's a much broader set of industries that rely on these capabilities that we're providing. The infrastructure work group, which doesn't really fit into the technology or the platform-specific bifurcation that I articulated earlier, it provides the standards, the specifications that define more of the infrastructure components that pull the various technologies and platform-specific specs together. And a couple of the standards that have been produced by the infrastructure specific work group in recent years, there's 3 that I can think of. The first one is the reference integrity manifest specification and set of specifications. There's an information model, and then there are some binding specs. And then there is the platform certificate profile. And then there is the TPM2 keys for device identity. And what those 3 specifications are trying to achieve is providing artifacts that allow an end customer to leverage the TPM attestation capabilities to attest to various things. So I'll start with the reference integrity manifest. In the PC client workgroup, we have the PC client firmware profile, and it defines the set of things that a platform must or are strongly recommended or must not measure into the TPM into specific platform configuration registers that are largely divided up by domain. So there's some PCRs that are for the BIOS. There are some that are for add-in devices, say option ROMs or Dixie drivers. And then there's some for the boot, host OS boot domain. And when the BIOS makes these measurements, it also produces something called a TCG event log that gives you some metadata as well as the digest that was extended to the TPM. And if you wanted, as a owner of a platform, to actually verify that the firmware that is running on the machine and the measurements that were made are what actually should be running, you have to trust that the machine that you received with the firmware running on it is good to begin with. The reference integrity manifest provides the missing piece that allows you not to trust what you received on your dock, that it hasn't been tampered with in the process of being shipped to you, because the reference integrity manifest is a signed statement from the platform manufacturer of what the actual code and configuration of that code were when the machine left the OEM's facility. And so now I can take the attestation capabilities of the TPM with its platform configuration registers. And the event log is interesting, and it's relevant for correlating specific measurements to specific events in the RIM, but I can compare it to a RIM instead of having to trust that the event log and the PCRs are correct. And so that gives me attestation from a supply chain perspective for the firmware and essentially the configuration of the machine as it's shipped. So things like the devices that are in the machine are represented in the ACPI spec that's measured. Things like the way the BIOS setup is configured, that's represented in measurements. So those are things that you can capture in the RIM and be able to know that nobody's changed, say, the boot order or added a spurious device in there. And that gives me, as a consumer of a device, the ability to have basically a signed statement from an OEM and that I can compare that machine to and know that nothing has changed. By the same token, the actual hardware that's in the system, the platform certificate defines an artifact that is modeled on an RFC 5755 attribute certificate. It links provably to either one of the TPM's endorsement keys, or it may link to an IDEV ID key, an 802, IEEE 802.1AR device identity key. It'll have information about the platform. So it'll have like the model of the platform. It'll have the platform-specific spec that it's complying with. And it has information about the TPM. And then it has information about the specific components that were deemed security critical. And the other spec that I'll talk about a little bit later, which is the firmware integrity measurement spec, and the upcoming update to that specification, define the set of components that we TCG think are the ones that are most relevant to be included in the platform certificate. But the information that's in the platform certificate is sort of the make, model, serial number, and revision of those components. And again, it's a signed statement provided by the OEM. And when I receive my machine, I can basically use the information from the machine and compare that against the certificate and make sure that nobody's added in spurious device, or make sure that nobody's removed something that was, part of my order. So now I have both capabilities. I can attest to the firmware and the hardware with those two artifacts. So the other thing that comes from the infrastructure work group is the TPM2 keys for device identity. So IEEE has a spec 802.1AR that defines a set of identity keys for devices. Typically, it's used in infrastructure. So inside of your network, you might have switches and various servers and other network components. And knowing in your infrastructure how to target specific things to specific devices is really relevant. And IEEE produced the standards to create essentially an initial device identity, which would come from the platform OEM, and then an LDEV ID, which could be created by the owner of the platform. And so I could create identities that would link into those specific things. And what the TPM2 keys for device identity defines is how you would use a TPM to produce those keys and the certificates associated with them. And so that gives you sort of a cryptographic identity for your system.
This plays back to exactly what I said at the beginning. It's great because you have that holistic, the bigger view, and very, very good. Really, really appreciate the detail. And by the way, I think what you've done really, really well is to show, that the TPM is not the only standard and not the only thing that the TCG is working on in terms of evolving the trusted computing concept, right? It serves as a basis, but there are many, many other standards and other specifications that we're working on that help that. I guess bringing it back to building all of the building blocks of security, right? That protect the identity or attestation, detecting and mitigating. I'm just going to throw one quick one in there. The cyber resilience, for example, is another one of those things that are there. So I really have to say is I think you've really done a fantastic job at showing exactly the breadth of the TCG work in developing all of these trusted computing specifications and standards. Now, you did go into a couple of other standards organizations. You mentioned ISO and a couple of other ones like it. What other, I guess, affiliated organizations like FIDO, OCP, et cetera, do you see leveraging TCG standards and specifications as part of their portfolio?
So FIDO has leveraged the attestation key, the original TCG spec for attestation keys that was done in the TPM 1.2 days. I'm not as familiar with the FIDO work, but I do know that there's some work happening there. OCP has a lot of work that they're doing, and I'm not privy to that. I just see the inputs coming in on the TCG side. The IETF, there's a lot of overlap with IETF. What we do is we take their standards for certificates and for attestation, and we then add TCG color or TCG. I want to say it's sort of tailoring, but it's not. But we take their standards and say, here's how you would use this standard in representing a TCG technology. So I mentioned RFC 5755. We also leverage RFC 5280, which is the X509 certificates. So that's leveraged in the IDEV ID key spec. That's leveraged in the platform certificate specs. The reference integrity manifest, the original spec we did was based off the ISO SWID spec. We've added support for CoSWID and CORIM, which are the basically IETF instantiations of attestation statements for things that are manifests. We also have another technology work group that I didn't really talk about is the DICE work group. And the DICE work group is another technology that is essentially a root of trust for measurement and reporting that is basically intended to target like components, like a component, like say a network controller or say a graphics controller or a embedded controller could incorporate a DICE within their silicon and use that as their cryptographic identity. And the DICE set of standards builds heavily on top of IETF standards for attesting to keys and things in that nature.
So I guess what you're saying is many organizations leverage TCG specifications and standards as part of their work, but TCG also works with other standards organizations and takes their specifications and their standards and then incorporates. So it's very much a two-way thing. Is that
absolutely, absolutely. For instance, our mobile platform work group has a liaison agreement with the Global Platform Organization. They do a lot of cross-pollinating of ideas, and it allows us to share information and work together to make sure that we're not competing in terms of our standards don't produce competing requirements or conflicting requirements.
Fantastic. Amy, listen, I could keep talking to you all day long. By the way, it's been really, really interesting to see all these different types of things. Unfortunately, we are running out of time in this podcast. So it's great to hear everything that we're doing from a TCG perspective, how we're working with all the different organizations. But in our next episode, we'll be taking a closer look at one of the more important developments of our time around device security, looking into the history and also looking at the evolution in the future of the Trusted Platform Module, or TPM. So Amy, thank you so much for your time. It's been a pleasure to have you.
Thank you.